Welcome to my class. Today we are looking into organic chemistry. We are diving deep into it. You understand? So I want you guys to focus. You understand me now? So we have to draw the following structures: 3-methyl-butanoic acid, 2,2-dichloro, 5,5-dimethyl pentylene, trans 1,2-dichloroethene, 2,3,4-trichlorocyclobutane, propan 1,2,3-triol, and propyl butanoate. So let's take our time and let's dive deep into it. So let's see. The first one says 3-methyl-butanoic acid. So let's see. 3-methyl-butanoic acid. Let's look at it. 3-methyl-butanoic acid. So let's see how it goes. Now, this is talking about alkanoic acid. Alkanoic, you can see oic. Alk is a general name. Alk. Like we have alkane, alkane, alkyne, alkanone, alkanoate, alkanoic acid. So we have this alkanoic acid. So that's the first thing to do. So that's the parent name. Butanoic acid. Butanoic acid. You see now, note it. So and the general formula for the alkanoic acid is RCOOH. You understand me now? They are called carboxylic acid. Carboxylic. COOH. That's the functional group. COOH. You understand me now? So R is the alkyl group. Alkyl group. If you see your R, and that group is having a general formula of CnH2n plus 1. You understand me now? And most time, 1 is for met. 2 is eth. 3 is prop. You understand? 4 is boots. So 1 met, 2 eth, 3 prop, 4 boots, and so on. So if I put n as 1 here, that's C1, that's H what? 1 times 2 is 2, 2 plus 1 is 3, CH3. So that C1 means C. This CH3, that's met. Putting n as 1, met. So this met. This YM, so we call it methyl. Methyl, alk is general name, methyl. So whenever you see CH3, we call it methyl. It's from the alkyl group. You understand me now? This methyl group. So don't forget this. You understand me now? Okay, that's for that. So if I now put CH3 in the first part here, but normally we start with 0, not with 1. In this alkanoic acid is a different structure from all this alkane, alkyne. So for alkanoic acid, you have to start your N as 0. Let's put our N as 0 here. So N as 0, that's C0, that's H. 0 times 2 is 2, is 0. Plus 1, that's 1. So see this C0 as 1. So which goes away. So we have H1. So we have H. So this R is the H now. This is H, then put your COOH. So that 0 is our met here. So this metanoic acid. Metanoic acid. That's putting N as 0. Now putting N as 1. That's now eth. So the 1 is the eth. 2 is now the prop. 3 is boot. You see now? So like that. Normally 5 is pent here. 5 is pent. 6 is eggs. So now what will now be putting N as 1? That's what C. That's this. If you do that, you see. So that's CH3 COOH. CH3 COOH. That's ethanoic acid. Ethanoic acid. You see now? The next one will now be putting N as 2. That's now what? C2. H2 times 2 is 4 plus 1, 5. That's C2H5 COOH. That's what? That's prop. So propanoic acid. So it goes on and on and on. Understand now? Now, what is now butanoic acid? The next one after propanoic. So that's putting N as 3. So let's put N as 3 and let's see what we have. So let's put N as 3. So hope you get this. So putting N as 3 now, that's going to be what? That's what? So C3, you can see H2 times 3, that's 6. Plus 1, that's 7. COOH. So this is butanoic acid. Because normally 3, focus on this C3. 3 is prop. So you add 1 to it. Always add 1 for the alkanoic. And that one is now boot. So this is butanoic acid. butanoic. You can also write it this way. Okay, let me, this is the molecular formula. Molecular formula. You understand me now? Now let's now write, no, this is not a molecular formula. For molecular, we write all the number of C, all number of H, and number of O. So now let us now draw the structure of this butanoic acid. Let's see. C3, 1, 2, 3. You can see C3. Then H7, H1, H2, H3, H4, H5, H6. You can see H6. So we have 1, 2, 3, 4, 5, 6, 7. This is where the R comes from. The R. The R is here now. The R. You know I say it's RCOOH. So just put your COOH. So we have C, double bond with O. You can see single bond with OH. You can see. So double bond, single bond. So this is the structure of butanoic acid. You can see now. So let's now see. Now I know I said the methyl, I said it is CH3. So methyls come into it, like coming into it like a branch, or the family of alkyl group. That's how that you see that how they are just branch chains. You understand now? So now let's put the branch now. That means put the meaning of it is that methyl, this CH3, will be in carbon number 3. Carbon number 3. So let me start. I can name from the front or from the back. If I name from the front, this C1, C2, C3, C4. If I name from the back, C1, C2, C3, C4. This is where you start from 1, because this is carbon atom that is having that OOH, the functional group. So the carbon atom having the functional group is seen as 1. So we now count to the back. Hope you understand. So we have 1, 2, 3, 4. So this is 1, 2, 3. That means methyl must be in carbon number 3. So this carbon number 3, 1, 2, 3. So I can just cancel this H and put the methyl, the CH3, I put it there. You can see. So this is the structure of 3-methyl butanoic acid. You can see. So it's very simple. It's very simple as ABC. You see now. So this 3-methyl butanoic acid. Thank you. So that's for the first one. Now let's quickly look into the second one without wasting time. Let's put the second one without wasting time. So the second one says what? It says 2,2-dichloro-5,5-dimethyl penthrehyne. Penthrehyne. That's from the general name alkyne. Alkyne family. Alkyne. Penthrehyne. Now what's alkyne family? CnH2n-2. That's alkyne family. C is taking N, the H is taking 2n-2. That's alkyne. So let's see. You know they said pent is 5. So that's C5, H, 2 times 5 is 10, 10 minus 2 is 8. So that's the parent name is pentyne, penthrehyne, pentyne. No, this is pentyne. So but when you say penthrehyne, you know what that means? It means the penthrehyne means that the hyne is the triple bond. That means the triple bond will be in number 3. So that's what is penthrehyne. So let's draw the structure. Let's see. C5. 1, 2, 3, 4, 5. You can see. So penthrehyne, you count the bond between C and C. So now the one, normally H should end this one and here. When you are counting your bond, not the bond between C and H. You have to start the bond from C and C. So 1, 2, 3, 4. You don't count it. If you are counting from the back also, you don't count the one between C and H. You have to count from here. 1, 2. So let me start from the front. Now, one thing about this thing is that there are two things. It's either you are given the names like this and you are asked to draw the structure. In that way, you can start from the front or from the back. But if you have been given the structure and you are asked to write the names, you have to follow some set of rules. You understand me now? So let's see. Let me start from the front. Penthrehyne. That means the hyne is a triple bond. The hyne must be in number 3 bond. So bond 1, bond 2, and bond 3. So this is a single bond. Let's make it 3. 1, 2, 3. You see now? Let me do this way. 1, 2, 3. Now you have to focus on this. Those carbon atoms that are sharing the bond, the CC, that are sharing that 3 bond, you are not going to write anything here. Because carbon atom can take a maximum of 4 electrons. So it can have 4 bonds. So this carbon atom is having 1 bond here, 1, then 2, 3, 4. The second one is having 1 bond here, 1, then 2, 3, 4. So you don't write anything up and down for those carbon atoms. That's how to know it. You understand me now? Why others you can write your H for this one. You can put your H up and down here. So that was the 23 ion. So now let's look at the branches. It said 2 dichloro. So number 2, carbon number 1, carbon number 2. That's where the chloro is. You can put one down. 2, number 1, 2, chloro. 2, 2, you can put up again because it's 2. 1, 2. 1, 2. So di means two things. 1, 2. Dichloro. Chloro is chlorine. Dichloro. Dichloro what? Dichloro 5,5-dimethyl. You know I said methyl is also branch. Just like chloro is branch. Anything aside H, they are all coming as a branch. So methyl is also CH3. I told you. So let's see. So 2 is the 5,5-dimethyl. That means the methyl CH3 will be in carbon number 5. 5, 5. So, you know we are counting from the front. 1, 2, 3, 4, 5. So your methyl CH3 can be down. You can see 5, 5. 1, 2, 3, 4, 5. You can put it up also. You can see. So this is 5, 5 dimethyl. So this is structure. So don't forget to put your H here and here. That's the structure of the compound. So the compound has 2 dichloro 5 dimethyl pentyliene. This is structure. You can see as simple as A, B, C. You can see. Don't forget to drop your own review if you think there is something I have not added or something. You can drop it in the comments. You understand me now? Okay, so that's for that. Now let's look at the third one. So before the third one, let me stop here. So I will continue in the next class. I will continue. Don't forget to subscribe to my YouTube channel to get this kind of video. So thank you.